Hey everyone, Tim here. Have you ever wondered what a musical instrument does? Okay, sure, it makes music. Duh. No, I'm talking about on a physical level. How does a musical instrument operate? Here, take a piano for example. We've all seen a piano before, but what does pressing a note on the piano even do? Better yet, how does the sound of a note get from the piano to your ear? You may have learned in physics class that sound is a wave, kind of like the waves in the ocean. Sound waves have two defining characteristics: frequency and amplitude. Frequency is how quickly the wave is oscillating. A more slowly oscillating wave means a lower note, and a quicker one means a higher note. Amplitude, on the other hand, is how tall the wave is. The taller the wave, the louder the note. The shorter the wave, the quieter the note. Okay, so frequency affects the sound, or pitch, and amplitude affects the volume. Let's try this on the computer. I used onlinetonegenerator.com to generate a sound at 440 Hertz, and it sounds like this. For those of you who play music out there, that's an A. Why doesn't this sound like the piano? The computer-generated note sounds kind of like it would be in a Mario theme song or something. It's really weird, actually. If we play an A on the piano, a standard musical tuner will tell us that it's actually 440 Hertz. But we set it as the same frequency as the one we made on the computer, so the two notes should sound the same, right? Maybe the tuner's broken? Alright, let's look a little deeper. I recorded the sound of an A on the piano, and then used some MATLAB code to graph the corresponding sound wave on the computer. Interesting. Doesn't look like a wave at all. This is because there are actually a ton of different waves in this diagram. If we use something called a Fourier transform, we can break up this jumbled mess into its different component waves, organized by frequency. Now, we can see our original A, followed by a few other frequencies that are evenly spaced on the diagram. These are called overtones. If we do the same thing for the computer-generated sound, we'll see that it doesn't have any overtones, because the computer is generating just the A we wanted. This is called the fundamental frequency. Okay, so the tuner wasn't broken, but it decided to give us only the information we need to tune, the fundamental frequency. None of the overtones or anything. Cool. So now that we know, when we press the key on the piano, not just one sound wave is emitted, but the entire overtone series for that note. The same thing happens with all other instruments, and that's how we can tell them apart. Next time you get a chance, see if you can guess which instruments are playing which notes in a song. Might be easier than you think. Anyway, hope you learned something new. Thanks for watching.